The construction of this project aims to discover each student diet patterns and student attitude toward healthy eating style by a simple survey given from Google Form. From the literature review, the linear programming model was formulated based on the daily nutrition to minimize Z. And the daily recommended nutrition suggested by Ministry of Health is carbohydrate is 180 gram, protein is 55 gram, and fat 46 gram. The data was analyzed using a solver, and what we get from this survey is minimum diet for student is RM13 ringgit per day.
Nowadays, obesity is seen as a serious health problem around the world, especially among university students. Obesity is caused by a variety of factors such as overnutrition, insufficient physical activities, changes in food habits, and social status. As for university students, most of them prefer to eat fast food rather than cook on their own. As we all know, fast food often includes a lot of salt, sugar, and processed chemicals that can be harmful to one's health. Nevertheless, students still choose fast food as their daily meals because of its availability, taste, and convenience. Other than that, even though the dietary habits could be changed by the student, the cost of healthy food is a barrier because most of healthy food are expensive than the unhealthy one. Therefore, this project was conducted to introduce a healthy menu diet to prevent obesity among university students as well as to minimize the cost of healthy and balanced diet.
In methodology, for us to collecting data, we are running a simple survey. The survey is distributed to 30 students of University Pendidikan Sultan Idris. The purpose of the survey is to discover the diet pattern of the student. The survey requires students to answer that the most preferred meals for their breakfast, lunch, and dinner. In addition, this survey also have aims to discover the students' attitude toward their healthy eating style. The choice of the menu are suggested, and the suggestions of the menu in the survey are obtained from the college cafeteria, while the nutritional content of each menu is obtained from the website of Ministry of Health in order to set up the LP model. To obtain feasible solution in this diet problem, this study considered three main nutrients, which are carbohydrate, protein, and fat. Since the student preferred different set of menu, the objective function and the constraints of each them are also different. The formulated constraints are based on the recommended daily intake of the following nutrient. So in this table, the nutrient for carbohydrate, the recommended daily intake are 180 gram, for protein 55 gram, and for fat 46 gram. Based on the recommended daily intake above, the linear programming models are set up as follows. Since the data collected is based on the menu provided by the college cafeteria, the LP model will be set up based on the price of the food determined by them. The following are the set of the meals suggested for the student.
So, I will discuss about implementation. The following are the choose of menu of 3 meal season in a day, choose by 30 students in table 3, and the nutrient content in each menu. So, hence, based on the information collected from this table, the LP model for 30 students are as the following. So, this LP model, we have discussed in this early video. So this LP model is solved using the Excel solver in figure 1. So you can see in the figure 1 is the Excel solver solution for 30 students. So the solver is designed to solve linear programming problem, and the simplex method is used to solve them. So the value of x will be determined using this solver in such a way that all the requirements are satisfied and z will minimize. So the solution found from the solver are discussed based on the price mainly and nutrients from those set meal. So the most suitable meals and have lower costs are suggested to the UPSI students in order to maintain their diet plan and healthy lifestyle.
To find the minimum cost, we use Excel solver to calculate the value of x that satisfies all the constraints, and z will be minimized. Excel solver will specifically to solve linear programming problems by choosing simplex method as solving method. The solution found from solver are discussed based on price mainly and nutrient from those set meals. The most suitable meals and have lowest cost are suggested to the OBESITY student in order to maintain their diet plan and healthy lifestyle. So as you can see from this final answer, final report, we can see that in the objective cell, which is for minimum cost. So the original value for total cost are 47 ringgit, and when we use solver to find the minimum total cost, we will get 13 ringgit 39 cents. Thus, as we can see from this table 4, table 4 stated the lowest to highest cost diet for each set meal, starting from 13 ringgit until 18 ringgit. The set meals that satisfied our linear programming, which is to find the lowest cost diet for each set meal, were the first set, which is set A for breakfast, set A also for lunch, and set C for dinner. Okay, for breakfast, set A only cost 3 ringgit, which is for cereals and fresh milk, while lunch only cost 5 ringgit for plain rice, steamed chicken, vegetable soup, and syrup. And also for dinner, which only cost 5 ringgit for bihun goreng and lemon juice. Although this set of meals are not student preference, since all of them have their different tastes, but this is the only set meal that satisfied our objective. Thanks, that's all from me about results from solver.
After formulating a linear programming model to determine the production levels that would minimize the diet cost, we also have solved the LP model, and now the corresponding sensitivity report by Excel solver has been generated. This sensitivity report is divided into 3 parts, which are objective cell, decision variable cell, and the last one is constraints. Firstly, I will tell you about the objective cell. The objective cell is the optimal value, which is the value reached when evaluating the optimal solution in the objective function. In this case, the optimal value is 47 ringgit, and using the Excel solver, we already generated the minimized cost, which is 13 ringgit and 40 cents. It is a minimum spend for a student to eat a balanced diet in a day. Second, the decision variable cell. In this section, we can identify the optimal solution, which are the values in the column labeled final value. The coefficient of parameters in the objective function means the value in the objective coefficient column. It is the cost of each meal served. Next, the allowable increase and decrease columns are for each of the coefficients in the objective function, which allow us to guarantee that the current optimization is maintained. For this case, if the cost of set A breakfast, which are cereal and fresh milk, increase more than RM1.72, the current solution is no longer optimal because it lies outside the optimality range. These are the ranges for variable and the constraints. Back to the earlier discussion, if the other sets of meals keep increasing, the solution is still optimal because the range stated is increasing until infinity. However, it has limitation. If it is decreasing more than the range situated, the optimal solution is no longer optimal. So the last section is about the constraints. One of the first aspects to observe is if there is an active constraint when evaluating for the optimal solution. An active constraint is satisfied when it is equal. From this report, we can see that only fat is an active in the optimal because it has the same value in the right-hand side column and the final value column, while the carbs and the protein is not equal. If we can see from the report, for the carbs, the allowable increase is 88.41 gram, so the right-hand side can increase by 88.41 gram without changing the location of the optimal solution. Any addition increase will change the location, while the allowable decrease is infinity, so the right-hand side can decrease by infinity without changing the location of the optimal solution. So from the report, we can see that the current optimal solution served is 268.1 gram, which is more than the recommended 180 gram carbs to be taken a day. The final value and the right-hand side constraint is not equal, so the constraint is not binding. This also applies to the protein. The optimal solution served is 73.24 gram, which is more than the recommended protein per day. So, it is also not binding, but the fat is binding as the right-hand side is equal to the final value. In the conclusion, in order to achieve the optimal diet plan with a minimum cost, we need to cut the carbs and the proteins that have been generated from the sensitivity report.
Healthy lifestyle is the key to have a better life. There are many ways on how to lead a healthy lifestyle. It consists of our daily activities and habits. First and foremost, we must start with our eating habit. Studies say 80% of the diet is coming from our stove, while the remaining 20% is from the exercise. So it is clear here that nutrition plays an important role in determining the level of health of an individual because it all starts from the kitchen.